This is tutorial number 2 or video number 2 that I'm preparing for the playlist which deals with dynamic modeling with the motion design app in the 3D Experience release 2025X. Okay, so let me remind you that for motion design I have two playlists. One of them is dynamic motion design playlist. The other one is the kinematic motion design tutorials. This particular one, because it deals with the dynamic analysis, is going into that latter playlist. So we have a block which has a mass of 777 kilograms, and I'll talk about why do you have this weird number, and it's being pushed with a force of 777 newton along a track, and there's no friction. Okay. So first of all, for dimensions, let me assume that the size of the block is 1 meter by 1 meter by 1 meter. So the volume of it is 1. And the track is 11 meters long. The thickness of it doesn't matter really. And I'm going to do the simulation over 4-second interval. Okay. Now, because frictionless, because the contact is frictionless, we have F equal to ma. We know F 777. We know M 777, and that's why the acceleration is going to be nice 1 meter per second squared. Now, because it's a constant acceleration problem, the velocity is acceleration times time. So over the 4-second interval, the velocity after 4 seconds is going to be 4 meters per second. And the distance traveled is parabolic, obviously, and it's going to be 1/2 at squared. And when you plug in a equal to 1 and t equal to 4, you get 8 meters. Now, let me remind you that the volume of this object is 1 cubic meter. The density of steel is 7,770 kilograms. So I'm not using that. I'm using only 1/10 of it. But I'm just letting you know that if this was made out of steel, the mass of it would be an extra 0 at the very end. We'll come to these things in a few minutes. Okay. And this is my disclaimer. Okay. This is one way of doing it, not the best way, but we're going to do the problem. All right. So let's go ahead and make the assembly. So let me go assembly design. I'm going to make the track first. So insert 3D part. I'm going to call this thing the track. And track. These are very simple parts, but I rather do it instead of me expecting you to go and do it yourself. So make it yellow, and let's go make it on that vertical plane. I will sketch. Oh, we have to go to the part design, of course. In order to do that, on that vertical line, we have to sketch. I'm going to draw a rectangle. That's going to be the track. So let me make this thing 1 meter. All right. And let me make this thing, for visual purposes, 0.25 meter. Okay. So we exit. This is the cross section. We exit and pad it by 11 meters. There. So this is going to be my track. Now I'm going to insert another part to the top, insert another 3D part, and I'm going to call this thing the block. Block and block. All right, let's go make it. Double click, go part design. On that same vertical plane, I will sketch a 1x1 rectangle. So this is going to be 1 meter. And this is also going to be 1 meter. Exit and padded by 1 meters. Let me also change the color of that. So right click properties, make it orange. Good. So we have made the pieces. Now notice that I'm not assigning any material properties to this. Okay. So let's go all the way to the top. And first of all, fix the track. We want to create a prismatic joint between the block and the track later on. And then a prismatic joint. It doesn't matter which one you use. I will use, for example, I don't know, yeah, this one. It makes no difference. So I want the edge of this block and the edge of this track be coincident, and this plane on the side and this plane on the side also to be coincidence. And I'm not going to control this thing, so I'm going to just delete that. We don't need this. Really, you don't gain anything by having it or not having it. Good. So we have a fixed part and a prismatic. Notice that I did not assign any material properties to it. So we're done. We're done as far as the assembly is concerned. Let me go ahead. Remember, we are going to go to motion design application. Now I have done this problem already by going into mechanical system experience and mechanical system design. But this tutorial is about motion design. You click on it, it's going to come back and say, hey, you don't have a mechanism. You didn't have a mechanism. If you did, would you like to select it? Well, I don't because I didn't have any. I say, okay. So a mechanism has been created right there. And it's got this stuff in it, and there are two joints in it, a prismatic one and a fixed part, of course. And there, if I expand this bodies, notice that there is something called track, which is going to be stationary later on. It is stationary, actually. And there's a block. If I double click on the block, this thing pops up. If I double click on the block, this thing pops up. And notice that it has a mass of 7,770 kilograms. Now, I did not even specify the mass, the density. But when you don't specify the density, it automatically puts the properties of steel on it. There we are. Now, I don't want this. Now, incidentally, look at this. Look at these IXX, IYY, IZZ, 1,295. And if the mass is that much, and from strength of material book, you look up the formulas, you're going to get IX, IY, IZ equal to this thing, 1,295. The thing is that my mass is not an extra zero here. I don't want that. So what I'm going to do is I'm going to go here and change this thing to override of mass property by value. Click on it. Now I'm going to make things 777. The problem is, and I don't know why these things don't change. They're supposed to change, but they don't change. I don't like it when you do this thing in mechanical systems design and mechanical systems experience. These things do change, but not here. But well, didn't change. I don't like it, but that's a fact. Even if you update and all these things, it makes no difference. Now, so what else do we have here? We have the joints, of course. We have the bodies, and it puts a gravity here of default value 9.81 downward. But we are not using gravity because there's no friction here. Gravity does not pay pay play a role, and therefore you can make it zero. You can delete it. You can just leave it the way it is. It makes no difference. Good. Okay. So now what we're going to do is, what I'm going to do is incidentally, I would like to, yeah, okay, so let's go ahead and do that actually. We go to mechanism, we want to apply a force right here, applied force right there. The question, it doesn't matter where I apply it, whether I apply it at the corner, etc., etc. Not really. So I'm going to say I'm just going to apply it at the corner. Okay. So I'm going to apply to this corner. Makes no difference right there. Okay. And it's going to be a constant value, and the value is 1,000 in the global X direction. Fixing the ground reference system, which is the global one. So we go 1,000. Sorry, not 1,000. 777 Newton. And then we say, okay. Notice that there is the icon here. The thing that's bothering me is that when you look at the icon, it doesn't actually point in the X direction. It points at the tilted direction. But I guess when they wrote the code, they didn't do anything about it. I may be wrong, but anyway, if I don't get the result, obviously I'm doing something wrong. But this is it. Doesn't matter what you put in there, what direction, it always draws it like this. I'm not sure why. Okay. So there is my force right there. Double click on it, you can see that. Okay. And then we say, okay, there's a lot of other things you can do. You can specify function, and then we're not going to worry about it. Good, good. Now, I also want to specify a probe here because I want to plot the velocity, acceleration, and all these things at the corner point. So kinematic measurement, this is the old probe here. I'm going to select the corner point here. Okay. And yep, so that's good at that vertex. Incidentally, what these things are, these show you these are for display purposes. For example, this one shows you that mass is specified there or specified there. Okay. Or we uncheck that. If you click on this force, show applied force, you click on it, it shows you that it's there. If you don't want to see it, get rid of it. Okay. If you want to see your joint, there we are. There's a prismatic joint here and a fixed point joint. Don't want to see it? Just let it go. Good. That's what these things are. Visualization purposes. All right. So now we're going to go to, let's see what we have here. Do we need anything there? No. We go to simulation, and we're going to create analysis case, create an analysis case. Oh, no, sorry, not that. Let me see now. It's already created right here. Analysis case has been already created. Double click on the dynamic step. Double click on this thing. It is dynamic. You want to do not kinematic, dynamic, and over a 5-second interval. Okay, that's fine. Oh, the 4-second interval. Okay. And then setting results for output. I want these are good. I don't have to make any changes here. All right. Now, first of all, this is a preview. Okay, it doesn't run it, but it's a preview. So let me click on it. So it's going, reset, exit. And then we're going to run it. Run analysis case. Wait until the results are created. If you select the dynamic step and go to results, you can do a play animation. You can make it go back and forth. It's in one direction. We can capture videos and things like that, but that's not what I want. Let me close this thing and click on 2D plot. Move this thing on the side. Now, this is very awkward, but that's what they have here. So let me go and look at the block and look at the X position of that plot. Remember, I created a probe there and say, add a plot, add a plot. You see, parabola. At the end, it's 8 meters. That's what this will say, 8 meter distance. Let's go here. Let's plot the velocity. Let me uncheck. Let me go plot the velocity. This is the position velocity in the x direction. That should be a linear plot going from 0 to 4. There, 0 to 4. You can see that. That agrees with this. And finally, if you look at the acceleration, must be constant acceleration of 1. What we expected, right? It's the acceleration of 1. Yeah. And then you can, transfer these things for the Excel spreadsheet and things like that. So we managed to solve this problem. This thing still bothers me, but it looked at it, gave us the right answers. Okay. So that's pretty much it. That's our first uh, video on the dynamic modeling with the motion designer. Very simple. Now remember that the strategy, my strategy in this playlist is to create simple problems, make sure that when I model it agrees with physics, and we just did because we had the analytical solution, and then it prepares us to do very complicated problem down the road.